Welcome to the office. We want to revisit an example that we just completed. We gave an argument for why a quotient group must be isomorphic to whatever it is that we found, right? So here we want to revisit that example. So we took Z12 cross Z15, quotient by this subgroup that's generated by 0, 3, and we gave an argument describing what happens as to why it must be isomorphic to Z12 direct product with Z3. Here, I want to use an argument that discusses the order of the group and the subgroup, and then order of the elements within this quotient group to determine what we must have. So what I want to do is I want to recognize, let's see here, I need a few different things. I have a relationship that's been previously established. So Z12 direct product with Z15. The order of this group is equal to the order of the subgroup, 0, 3, multiplied by the quotient group, this is the number of cosets. So Z12 cross Z15, quotient by, it's generated by 0, 3. Right, so I have this relationship. Because the number of elements times the number of cosets gives us the order of the group itself. I believe that is essentially the statement of the theorem. So Z12 times Z15. Now I know this is order 12 and order 15. Do I know off the top of my head what 12 times 15 is? No. Could I figure it out? Certainly. But what I do know is I can recognize that 12 can be written as 2 squared times 3, and that 15 can be written as 5 times 3. So overall, I get 2 squared times 3 squared times 5 is equal to, and I know from our previous work that this is a subgroup of order 5, and I still have this is multiplied by the order of the direct product, or sorry, order of the quotient group here, or factor group. So write that down again. All right. I can cancel out or I can divide both sides by 5 to get that the order of this group, 4 times 9 is 36, is the order of Z12 cross Z15, quotient by was generated by 0, 3. So this argument that we're working through now will work for a large variety of quotient groups. When we're taking the quotient by 0, or it's generated by 0 comma something or something comma 0, that very easily fits within our previous example. But I also like this one just to see the connections between the two ideas, that we can get the same thing. All right. So since we know that the quotient is order 36, if I just call this G, right, the order of G in here, this is our group G. That's the normal subgroup that we're taking the quotient by. So we know that the quotient group G mod N is going to be isomorphic to several possibilities. What groups of order 36 are there? So we have the possibility of Z4 direct product with Z9, or it could be isomorphic to Z2 direct product with Z2 direct product with Z9, or Z4 direct product with Z3 direct product with Z3, or our last possibility, all of those factors individually, Z2 direct product with Z2, direct product with Z3, direct product with Z3. So we have these 4 different possibilities that it could be. So the key is to observe the order, of elements. All right. So if we notice 1, 0 here, plus, so we're talking about a coset here, this particular element plus the subgroup generated by 0, 3, right? We said earlier that that first factor, that first group is not affected by the quotient. So what's generated by 1, 0? Well, it's still all of Z12. Well, I mean, not Z12, but Z12 within this quote or within this direct product. So this is an element of order 12. So since I can immediately identify an element of order 12, so observe this. So we must have, we want to consider what the possibilities are. This, for example, I can find an element of order 4, and I can find an element of order 3, so that makes sense. This one, I cannot find an element of order 4, so I can't get 4 times 3. This has an element of order 4, that has element order 3. This does not have element order 4. So what I'm saying here is this I can get an element of order 12 out of. This I cannot get an element of order 12. This I can, and this I cannot. So we must have that G mod n is isomorphic to Z4 cross Z9, or that it is isomorphic to Z4 cross Z3 cross Z3. So we must have one of those two scenarios. And what's the difference here? Well, this has an element of order 9. This does not have an element of order 9. So what can I do? Well, I've collapsed my direct product by 5. So what happens is elements are going to either stay the same order, or their order is going to be divided by 5, right? Compared to the original elements in this direct product. So this element here, the order of it didn't change. Some elements will have a smaller order, but that order is going to be divided by 5 or a multiple of 5. And therefore, we notice that our original direct product, Z12 direct product with Z9, original Z15 there, has no elements of order 9. Now, 9 isn't the only thing that I'm concerned about. I also want to concern myself with elements of order 45, because if I take 45 and divide it by 5, then I'm going to, again, get that 9. And then I can't have, what's 9 times 25, right? That's too big. Our original group did not have an order that was larger than that. So I can't have any elements of order 9. Or I didn't in the beginning, or 45. How do I know that? Well, what would it look like to create an element of order 9 or 45? I can't have 3 and 3 because that's just going to generate an element of order 3. I would have to have an element of order 9 in here, or an element of 9 in here. And same thing with 45, right? That's obviously can't happen because neither of those are large enough to have an element of order 45. And 9 doesn't divide 12 or 15, so I can't have this element of order 9. So G mod n cannot be isomorphic to Z or direct product with Z9. Hence, we do have that G mod n is isomorphic to Z4 direct product with Z3 direct product with Z3. And of course, if you take a quick look here, Z4 cross Z3 is isomorphic to Z12, so we do have that this is also isomorphic to Z12 direct product with Z3, which is the same thing that we had said in the previous example, right? So we have the same conclusion. We phrased it a little bit differently, or looked at it a little bit differently, obviously with a different argument, but this gets us the same final result. Awesome. Thank you so much for your time and attention. I hope that that was informative for you. Let me know if you have any questions.